Hi everyone, welcome to this new lecture of fluid mechanics. In this lecture, we'll discuss the concept of horizontal plane surface and which is immersed in the or submerged in a liquid. So the concept of this horizontal plane surface submerged in the liquid is that we need to consider a liquid container which is in the static condition, and we need to consider the horizontal plane, and that should be immersed or submerged in the liquid. So let draw a horizontal surface or it's a liquid surface line. In the previous lecture, we have completed that vertical plane surface which is submerged in the liquid. Suppose this is the liquid surface is there. This is the upper surface of this liquid. This is the surface of liquid, we can say, and the liquid is present here, and this liquid actually in the static condition, or you can say the rest condition. Now here in this liquid, now another things we need to consider the horizontal plane. So horizontal plane, we can consider any kind of plane surface. So let's consider a rectangular one, and this is a plane surface is there. Okay, and this plane I need to be immersed in the liquid. Okay, so in the previous lecture what we discussed, there is a vertical surface is there, and the vertical surface is immersed in the liquid. So in that case, that vertical surface was like this, and now we need to consider a horizontal plane surface. So let me draw a horizontal surface here, and that is the position of this horizontal surface is it is immersed in the liquid. Okay, now I can draw like this. So let's consider this is the horizontal surface which is placed inside the liquid or submerged in the liquid. So here what we can find out, or what we can get it here, the distance from this liquid surface to this point. Okay, and let's suppose this is the line which is present in the plane, and the height from this liquid surface to this plane or this horizontal plane surface will be equal in all this position, where if I measure the height from here to from this liquid surface to this plane also will be same, or if I measure from here or from here, any point, if I measure the distance from this liquid surface to this horizontal plane surface will be the same one. That will be not different one, same distance will be there. Now here if I want to find out the center of gravity point and the center of force point on this plane surface, I can get, let me draw this horizontal x line and y line on this, and the point what we'll get here, so that will be the center of gravity point of this horizontal plane surface. And similarly, the center of pressure P point or the pressure force will be acting on the same point of this, because the distance which is covered from here, all this everywhere the same. Okay, so we can write here the height of this, okay, from here to here, that is h bar, or the distance from here from the free surface to this P point, or we can mark it as the h star also. So there is no difference in this, so both will be same location is present. Okay, now the concept here we need to find out that what is the pressure force acting on this, and what is the center of pressure is present on this location. So center of pressure, we can see the height from here to the center of pressure, and the height from this liquid surface to the center of gravity h bar is both are equal. Okay, so the pressure which will be acting on this horizontal surface will be similar on all these locations, all these positions. If you see, if you apply here what the pressure here, rho gh, here also the same rho gh will be there, everywhere same pressure will be applied. But in the vertical case it was different, because the height matters. What is the height of that vertical surface, and the position from here to the liquid surface, how much, right? Based on that, the center of gravity used to vary, and that to be it depends upon the types of object or surface what we are considering. Okay, so for this condition actually we need to find out what is the pressure force acting on this. So we know that the pressure which is acting here uh, in the surface, that we can write P equal to rho gh. Okay, this formula already you have derived in the previous lectures. And the area is the cross sectional area of this plane surface. And while calculating the pressure force in this, we know that we can write this pressure equal to, also we can write, force by area. And similarly we can write this force equal to pressure into area. So if I want to identify the again force value here, so I can just put this value P rho GH in this equation, and I'll get rho GH into area. Now here the H value, what is there? You can say the H value is the height of this from here to here. So that one we can consider H bar. So that is nothing but rho G H bar A, and this is the force, or you can say the pressure force which is acting this, or the total pressure which is acting on this point, you can say. So this is the formula of this. What already we have discussed for the vertical one, that was different, and now here it is both for the both condition, it will be both will be same. So also we can write the same H equal to H bar equal to the same height, also equal to, we can write the H star, because all are placed in the same height from the surface of the liquid. Okay, so this is the concept of this horizontal plane surface submerged in the liquid. Okay, this is the liquid surface is there. So why it is required, why it is necessary, as I already told in the previous lecture, that while constructing the dams or tanks or any big pipelines will be there, we need to see that from the surface of the liquid and what is the position of that any kind of surface will be there, and then how to identify the height and how to identify the total pressure of that, and what is the center of pressure for that particular point. So this will be helpful for that. So let's solve one problem related to this horizontal plane surface submerged in the liquid. So here I have considered a problem. In this, the figure is given here, this one, and which shows that the tank is full of water. Okay, and the tank is given, this width is 0.4, and the total width of this is 4 meter, and this height is 0.6, and total here from here to here 3 meter is there. And what you need to calculate, figure shows the full of tank of water. Find the total pressure on the bottom of the tank. We need to find out the pressure on the total bottom of the tank, weight of the water, and the next one is the hydrostatic paradox between the result A and B. And this hydrostatic paradox is nothing but, actually we can say, it's a liquid pressure at all the points. Suppose if you consider this is the depth is there, this is the surface is there, so for all the points, what is the pressure acting on that, or what is the pressure of all the locations which is below the water level. So let's first write down the data given here. So I can say what are the values are given for this. Let total height here we can write the H equal to, we can write from this point to this total liquid point, how much is there. So that one we can write 3 meter plus 0.6, so we can write 3.6 meter. And here the width of this we can write was given, actually one more width is given, actually that is not mentioned here. Width of the tank is 2 meter, so that's supposed to be in the question. Width of the tank is 2 meter, so that part is missing. So we can write width equal to 2 meter, and this one we can consider the width in the sense in this way, the total height, length and width tank is there, and suppose we want to, okay, it should be like this, and this will be the height, Similarly, this is the width part. This part actually 2 meter, and the length of this tank is given 4 meter. This is the length of the tank, 4 meter. So these are the dimensions are given for this tank, and here we need to find out the value of force, what is the total pressure acting on that. So we know that the total pressure force equal to rho g, previously just now what we have discussed, rho g h bar a. So h bar and a. So now here we need to find out the area. So area we can calculate, that area what we can consider here. So what is the width of this and what is the length of that, so that we can calculate the area. So area equal to, that will be 2 into 4, so that is nothing but 8 meter square. And similarly we can find out the value of force on this, and that will be 1000, because water we have considered here. So rho, that means density of the water equal to 1000 kg per meter cube, and this one 9.81, and into area 8 meter, and this h bar, that how much height is there, that is 3.6 is there. So that one we can consider 3.6. Now if you multiply all these things, let's see, the help of calculator we can calculate it, how much it will come. 1000 into 9.81 into 8 into 3.6, 282,582. So that is 282,528, not 82,528, and this is the Newton. So this much force is acting on it. And similarly, next one we can calculate this is first one. This is first one, and second one is given weight of water in the tank. So that one we know that weight we can calculate. W equal to, we can write mg, and from that we can write rho vg, because we know that the density equal to mass by volume, and we can write on place of m we can write rho v. So just put the value of this rho v in place of m, we can write rho into v into g. So what is the rho value? We know that water density 1000 kg per meter cube, and volume we can calculate that one, volume equal to all this multiplication we can do that one, and this is 9.81, and this will be volume we can write here. So total how much will be there for the volume for this, we can write 3 into because here it will be different and here it is different. We can see the shape of this, or this will be different, and this shape will be different. So that's why what is the width is fixed, that is 2 meter, and for this we can write 3 into 0.4 into 2 width, plus this one will be again similarly 4 into your width is 2, and this height is 0.6. So this will be different. So that means we can write 1000 into 9.81, and this will be 6 into 0.4, that is 2.4, and plus this one 8 into 0.6, that is 4.8. So if you multiply this one, then near about how much will get 1000 into 9.81 into here it is 6, and this is 7.2. So near about 70,632. 70,632 Newton. So this is the weight of that water in the tank. Okay, so see the pressure force which is acting on the tank is 2,82,528 Newton, and while the weight of this tank is, water in the tank is 70,632 Newton. And the C point, what is telling, the C point is defining, what the hydrostatic paradox between the results A and B. So what result we got here? So we can find out that the total weight of the water, how much? This is 70,632 Newton, and whereas the force due to the pressure at the bottom of the tank is 2,82,528 Newton, and the weight of the water in the tank is much less than, you can see this is 3 to 4 times. How much times will be 28, 4 times about. So this is much less than the total pressure force at the bottom of the tank. And actually this concept is known as the hydrostatic paradox. So between this relation between this point and this one. Okay, so I hope you understood how to solve the problem and what is the concept of this horizontal plane surface submerged in the liquid. If you are having any kind of query regarding this, you can give a comment on the comment box. Thank you all.